Good morning, everyone. It's 10 o'clock in Eastern European time, and on the list is 11th Academy. And as ESSVE Academy year started in March, April, and ending with February, March, then we still keeping the numbers ongoing. So it's a new year, all the success for everybody who is participating in our academy running. And I kindly ask you, DR, to release those incoming people who are behind the screen, so I can go on with the academy itself here. Today's subject is fastening rafter to beam or similar connections, either one with fasteners or with a bracket. And picking up here agenda of the day, then shortly, quick 5 minutes intro. Then we're gonna have the application case study. For that, we have a senior lecturer from TalTech University and structural engineer Eero Tuhkanen with us. Eero, hopefully you are there. Yes. I saw you there. It's super. Your sound is coming through as well. Thank you. Then we show you a sample of S-wood, and I have print out also a sample which you can have it by email after the academy, how to have different options here. But shortly about ESSVE itself. ESSVE is, let's say, a fastener leader in a Nordic region. We have over 1,100 Nordic retail and distribution areas. We are founded in 1970, 7 offices in Nordic area in European countries, roughly 200 employees. We are a part and member of the Bergman and Paving Group. And the fun fact is that roughly 5 million ESSVE screws are sold every day. So this is a little bit about us, then about our product range. We can say that we have a foundation and structure, we have building envelope, interior finishing area, and outdoor carpenter area. And today we would like to go towards to that area which is called timber and glue lamp CLT. More detailed issues we will talk about CLT next time. We will introduce that time in end. And previous time we were talking about concrete. So here is also a slide about concrete itself. You can find the concrete software in our website. If you don't find it, ask support. We have also a new released technical email address called engineering@essve.com. So you are welcome to send requests over there. Myself, I'm Enno Rahuja, located in ESSVE Estonia. I'm in ESSVE product group technical engineer, experience more than 25 years in fastening business, and in right-hand side you will find my contacts. About S-wood itself, we have in our software 2 applications, but some of you probably have used the software. If all of you is super. Today's question also on the poll will come here that have you found that we have in lateral application, also axial application. And I will release the ball here and wanted to get your feedback that how many have recognized that there is existing as well axial load in our software in area of lateral connection. And in a chat side, you can see the poll result. At the moment, roughly 40% says no. There is some of them who have used it 30% and who haven't used it 30%. But it will change time and everybody will give their responses. At the moment, just 15 responses have been given. But this is today's subject actually. And we going forward to show you now. And for that reason, we have here Eero today. And this is the picture from this, what you're going to receive it later on by email. But as we have it time for Eero, 5 minutes is over. My intro is done. Eero is coming from TalTech Estonian University, and he's also a member of Estonian Eurocode delegation. So all open questions are welcome. You can put them in the chat field, and after Eero presentation, we are ready to hear your feedbacks or your questions. Eero, floor is yours.
Thank you. I also wish everyone a successful year. Better late than never. And I will share my presentation. Can you, Anna, confirm that you can see the presentation?
Yes, you are on the picture.
Thank you. So it's good to be back here. Today's example is about rafter connection to the purlin and the wall plate. So this is the topic we usually consider in small buildings. So I think this is mostly the domain of self-builders or the people who build their houses. They almost never calculate the angled roof, and the connections there is more like experience-based, but sometimes we need to calculate that to be sure that the structure will hold as it has to be. Before I go to the connection itself, I go through some challenges which are related to the roof design. And I can see that when I work with students and when I work with engineers, sometimes it's challenging to find the loads in the roof. Oh, someone is speaking as well. Henno, can you please?
Yeah, I'm looking the voice to
Okay. Yeah, so the first challenge is related to the finding loads to the roof, and the thing is we have to consider first the self-weight, then the snow load, and also the wind load, which is quite complicated load on this kind of roof when we have, for example, a two-pitch roof. And the problem here, or the challenge here, is how to summarize all these loads, or how to put them into one combination. And then we have to play around how is the angle of the roof, how the load is acting on the roof, in which direction is the wind blowing, is it blowing or is it the negative pressure? So all these things we have to consider. And it's also important if you use the software, let's say finite element software, then you also have to know how to input the loads to get real values. For example, for slow load, which is projected load, not the load entirely on the roof. The next challenge is related to resistance of horizontal reactions. So when we have two-pitched roof, we can always get these horizontal forces, and this is the simplest roof structure here. You can calculate this basically by hand. You don't need any particular software, but the challenge here is how to take this horizontal reaction here. So the simplest way is to use timber itself, or use the floor structure for that, or I found some old solutions in the book where you can use, let's say, concrete floor with a special shape to take the horizontal forces as well, in addition to the vertical one. And also we can anchor the timber to the concrete floor to fix the rafter to it. So this is the next challenge. From my own experience, when you have very, let's say, big span, you don't have any other choice only to use so-called steel shoes, so that the rafter can go into it and it can take the horizontal force. There is no way to make this connection timber to timber, for example, because it's too big. One example here, how to handle this problem is we can support the rafters by purlins. So here we have, for example, two steel beams. On the right side, you can see the other building. This is not related to the left one. You can here also see that there is a steel beam going through the building, which supports the rafters, and the rafter is fixed to the beam, and also the wall plate, or how we call that here under. This solution is useful when we cannot take the horizontal force here on the bottom. For example, in this building, this is because of the architectural reasons, it's second floor, which is not starting from the first floor ceiling. We have here a part of the wall, which is also timber, and this part cannot take horizontal force, and we cannot let the horizontal force into this structure here, and that's because we use these purlins on top of it. You can also see that here on the picture inside, where is the steel beam. So this is one way to handle the roof structure. And the most worst case, when we don't have option to make here the collar tie in the right place, we have to move the collar tie higher because of the requirements of the room. Here is a coming sport hall where this roof with the rafters is supported on one side to the concrete beam, but this concrete beam can take horizontal force or cannot take too much horizontal force. It is allowed a very small deformation here in the support side, horizontal deformation, and this roof is calculated so that the deformation here is minimized. And the final fixing is made here to the concrete part after putting the roof structures or stones onto the roof to let during the building process, so the rafter can take the final place, and then after that we fix that. But this solution is very produces very heavy moments in the rafters, and that's because the rafter cross section is huge. But these are all so-called special cases. In normal buildings or small houses or private houses, we have simple timber structures, and I think I can make a poll. Does anyone calculates the angle brackets in such a structure, or just put some angle bracket there? But we have option to calculate angle brackets. Angle bracket can be reinforced or strengthened angle bracket, and we have the calculation rules. In the new Eurocode, there is a given note about the angle brackets, but not specific calculation methods. The specific calculation methods you can find in angle bracket documentation or ETAs. And the angle bracket can take forces in different directions. And when you have a combined loading there, you have to summarize all of them, the loads and the resistance. But the thing is that the model we need to calculate the angle bracket is quite complicated, and we need a lot of time to calculate that. And some producers give, instead of the load bearing capacity, or instead of the model, they are giving the coefficients to calculate this angle bracket more easily. But as a principle, it's quite complicated system. So the other way around, how we can fix the rafter to the purlins or to the wall plates is a screw solution, and the screw solution is much more easier. So it can be complicated when the rafter height is too high, but we can solve that as well. But the principle here is that we take the force which the rafter have, or what is acting here, we take this with one screw or with one screw pair of screw. And here I made some simple structure. This is the way we can design the roof structure. Here is an optional version where we have also purlins and the beams between the purlins. This is not only the work for engineer, but this is also work for architect, how to design this structure, considering also the room inside the building. So you have to consider that during design. But here you have to pay attention on two things. When you have purlin which goes through the building, the purlin is supported by columns usually, or some walls which are internal walls. And when the purlin is supported to the column or wall, then the support or imaginable support for the rafter does not deform. But if you have a rafter between the columns, then the purling can deform, and then you have to consider this deformation of the purlin as well. So it's very good if you can calculate that with finite element software, because it's it's quite complicated to do it by hand. However, if we find the right cross section and we need to anchor the rafter to the sole plate or wall plate, how you call that, or to the purlin, then you have to consider possible horizontal force in this rafter, and also negative pressure from the wind, which will uplift the roof. And then we need to find how much force we have to take in this connection. And here is a principle. If we have these reactions from the calculation software, we can find the resultant or the force which we have to take with the screw. And we can divide the force in two. So there is an axial force which is pulling out the screw, and there is also lateral load, which we have to also consider. When it's very small, I think you can neglect it, but when it's bigger, then you certainly have to consider that. And here is the formula how to consider these two forces together. One is the pull out and one is the lateral one. Here on the right side, if you remember from the spring, we talked about characteristic withdrawal resistance, which is new in Eurocode, and how to consider that. We have this characteristic withdrawal resistance we have to consider in this case. This is this FAX TD. And in the new Eurocode, the characteristic withdrawal resistance is calculated based on screw circumstance, not only the diameter. And also there is a characteristic withdrawal strength, not withdrawal parameter anymore. And if you are using the screw, which is according to harmonized standard, you can calculate the withdrawal strength according to this formula. And the K-screw value here, the default value in the standard is 8.2. But if you are using the screw, which has ETA document, for example, ESSVE ETT screw, then you have to calculate this K-screw value according to the withdrawal parameter given in the ETA document. I can say that for ESSVE screw, this K-screw value is 9.4 or 9.5 something. So you can get benefit from that. You can get higher value than the harmonized standard screw. So it's better. So this is the simple principle. Here I have a tip. Enno already mentioned that if you go to the ESSVE calculation software and you choose a laterally loaded connection, then you can see that under the load section, there is, in addition to the shear load, also axial load possible to implement. It means that you can basically model this rafter to sole plate system. It doesn't matter that the sole plate is not under certain angle, because for the calculation the screw is still under 90-degree angle to the wood, but you can put here this shear load, which is here, this lateral part of this load here, and the actual load you can add directly, which is here on the last slide, this FAX, and you can find does it take the force or not, so you can get some benefit from the software here. And let's say if you have to high rafter, you can also make this connection with a crossed screw. I also found a picture from internet where it is done so. But here, if you calculate, you have to consider this additional angle part as well. So this screw is not pulled out directly. It's you have to recalculate this this angle. So this is all from my side today. This worked example will be more deeply as a calculation example in a couple of weeks. So I think you can have that in coming weeks. So thank you.
Thank you also, Eero. As you kindly asked me to raise the poll question, I did it actually. So to get the feedback, what do you use? Do you use that bracket in such a connection today or not? So you have a choice to give Eero feedback here with the yes or no answer, and you are welcome to yeah. At the moment, just 10 response. Now it's getting 20. Still, we see that roughly 80% is using angle bracket on that application. So it's.
Do you also calculate?
Yeah, it's. But it is good to see that such a easy tip to fix with the faster is existing. And as it is time for your chat field also to raise the questions, or you can open your microphone and ask it directly, then you're welcome. If you don't have questions, you can always write an email or later on put it in a chat. We will look at also the day a little bit up to noon, whatever questions have been coming. Good to get your contacts there, and then we send you the direct feedback by email or giving you a call. So it's a question time here. If we don't have any questions coming in, I'm looking at chat field. Then I have to go just step forward. We have 3 minutes to go. Remind you that there is the ESSVE also possible to use on mobile phone. You can shoot the QR code and go within, or you type it essve.com. You get it directly there. Another point is that our next academy is in February 11th. And the next academy, we'll see, we get it now, 12th academies together with Eero. So it's his time to also talk about CLT joints. Then we stepping forward to introduce something more about CLT, but those news we're gonna talk about next time. If we look at who's gonna support you here in Eastern Europe, then Today, Radoslav is missing. He's in flight mood, going to another meeting. DR is with us, and he is our structural engineer for all ESSVE group. And I'm here for Baltics to support you on technical sales. So you are finding our contacts here. So if you like to have a ESSVE demo, feel free to contact me. I remind you that it's not here on the picture, but we have engineering@essve.com website available. Not website, email available. And you are welcome to send us also request there. And as we have arrived to the end, I will look for
we have just a question, Eero.
Super, go fair.
Yeah.
Go.
Yeah, it's from Arina in RAS.
Oh yes, can user import loads combination resultant values from external software? Like, I personally don't know. You mean import to the ESSVE?
Yeah, in the program you have two alternatives. The first alternative that you put like practice load and add the safety factor, but the second one that you just put the design load in the program. Yes, the answer is yes. You can just put the design load, which we recommend it. It's better to have it like that.
Mm-hmm. Yes, you can check both directions together. This is this summarized check where both directions are considered.
Yeah, and there was additional questions. He asking if the combination is more than 1,000. Honestly, we don't have tested for 1,000 more in the combination, but you can check it to see what's the reacting. I think sometimes when it's very special load, not followed up, but you can test it. Can shear load be checked in the both direction with axial load also? Yes, the answer is yes. As you know, yeah, you get the answer yes. As he showed in the program, you can put both the axial and the shear load in the connection.
The picture comes here that you can turn around, you can even put an angle, those loads which are from the shear, and axial is here from the both direction, it calculates in it. Yeah, and the sample I will send you, I have even tied in the fastener to 80 millimeters. So you can also settle there a distance, how deep you want to go with the fastener. So if you have a hidden type of fastener like ETT or full threaded or cylindric headed screw, then you are able to dive in also into that rafter.
And you have another option too, that you don't want to have the shear load not 90%. You can have it like with the parallel with the rough, and you can get the vertical and the horizontal at the same time. You get the analysis from the program. That means you will get horizontal load, vertical load, and withdrawal load at the same time.
Okay, so basically that means that if there is no there is no possibility to add like shear in two directions, but you like calculate what is the approximate angle and the summary of that vector. Yes.
No, you can put the load that you see now in the figure. You see two loads, one with parallel with the screw, and the other is perpendicular to the beam. That perpendicular with beam, you can have it with angle. You don't want you can have it more than 90 degree. You can just open. Do you have program open arrow so you can show to them?
No,
Yeah,
no, I
and,
don't.
I can go it from Lithuanian website easy in. It's timber deck here. Yeah, we can
You
go
don't
for.
show your program desktop.
Yeah, I will move it up here now.
Yeah.
I quick log it in. And when I go here on calculation side, then
you
this
see
is
there's like that, and if you change the this is the secondary beam. If you go down, if you go up more,
you can change here
Yeah.
that shear load angle, whatever you wanted to have it. Like we had it 180, then you can have it this way, the load. And as you see, there is no axial load at the moment, but if you give here a value, then you will have also here the axial load available. And you build up your parameters how you want it to have it.
Yeah, but basically what I meant is that if we have a image like this, can I apply the load also vertically and horizontally and in the axial direction, or is it just one shear load that needs to be applied at an angle?
it's just one shear load.
Okay, thank you.
All right.
Yes.
As we are in end, do we have some more chat questions?
I have one question for Eero Tukkanen.
Yeah.
Can you comment how far along the Eurocode 5 next version is?
Sorry?
Can you comment how far along the Eurocode 5 next version is?
It's ready.
It's ready, okay.
Yeah, and officially it will be implemented, or it's better to say that the old one is ending 2028, but the new one is already confirmed. I don't know yet if it's available in the EVS. I'm not sure, but yeah, it's already. They are already making the annex, not annexes, but how it's called, yeah, not the annex, but yeah.
And we in ESSVE we have already started to compare the H distance and the S distance between the old one and the new one. If be honest with you, I was surprised because the new one is much easier to follow up the end and the H distance compared to the old one. I see this many advantage with the new Eurocode. And we're working on it to have it in our next generation for structure handbook.
I have in a question field also from Riho and Rasmus a question that what means that the overlapping member must be a parallelogram?
But I don't understand what's the question over that must number. Okay, yeah.
It's just an error in the software, not an error, but just a comment in the software.
It's not error in the software. This is just wording in your in the program that they say the connection area between the main member and the second member must be rectangular, must be full area. Otherwise, if you just change the secondary beam to, we say, to 45 degree, you know?
Yeah, I will change it here, then you will see it.
Yeah,
and
this still you have total connection between these two areas. If you change this 200 in the bottom of that, the secondary beam to 118, something like, no, yeah.
Then it gives an error sign.
Yeah, if you go up, you will see the error side. If you go up in the program, you will get the error side. But in sometimes, like you are a structural engineer, you have not 100, you have 190. The contact area is almost like missing 5 or 10 millimeters. You can do like your engineering's the solution. Say, okay, I will calculate it like 100% contact area, and for this 5 or 10 millimeters, does not have any matters. Yeah, that's what mean with everlasting number must be fulfilled. Yes.
Like this.
Yes.
All right. Then I will release a final poll question here, which is just to get your feedback. How did you like it, today's academy? So we get the feeling that are we in the right track or are we in the wrong track? So you are welcome to give us a feedback. Thank you very much. We are 10 minutes over the academy time, but I'm very happy to have the questions from your side. So feel free to give us a feedback, and see you in next time, which I think was 11th of February. So you are very welcome to register whenever we're gonna sign up the newsletter again, that the next academy will happen.
And if anybody want to have a more deeply discussion about the program and some special case, we can arrange some visit to you and visit your company and coming there and show how the program working, and some tips on tracks how you can optimize your solution. Yes.
Thank you.
Yeah, thank you.